So yesterday we learned a little bit about proportionality and kind of how that rolls. We learned about proportionality from a graph. We learned about proportionality from a table. Someone dazzle me with their knowledge of how to determine if you have a proportional relationship from a table. Bennett?
Scale factor and the constant remain the same. Like,
Wait. No. That's not what I'm looking for. Well, okay, wait. Give me a better description. I don't even know what scale factor had anything to do with it. I said I want to know how you determine if you have proportionality from a table. There's a rule that we discussed that enables you to determine if it's proportional from a table standpoint. Labib, happy birthday. Wait, listen up. Say again. Perfect. If you do y divided by x for every single value, and they give you the same number, all except for 0, 0, right? If you do y divided by x, that gives you what's called a constant of variation or constant of proportionality. That k value is what tells you if the table is proportional. Why are y'all raising your hands? I haven't even asked a question yet. From a table? Nope. That's the only one I'm looking for, because that's the only one I discussed yesterday. Okay? No. I didn't. Thank you. Didn't select you. Look at that. Listening skills. How do you determine if a graph is proportional? Clear? Linear and goes through the origin. Perfect. Concise. Exactly what I'm looking for. Has to be linear. Has to go through the origin. So let's start with number 1. It says complete the table and then graph the function y equals 1/2 x. So first we need to fill in our y value. So basically the way that works is in order to get the y value, we simply plug in the x value, do the math, whatever it tells us to do, and then we're going from there. Jonah, that's making noise. Thank you. Okay, so what is negative 1/2 times negative 2? 1. What is negative 1 times negative 1/2? 0.5. 1 is negative 0.5, and 2 is negative 1. So let's go ahead and graph those. So we have the point negative 2, 1. Remember, we go to x value, then y. So we have a point here. Then we have negative 1.5. Then we have 1 negative 0.5 and 2 negative 1. Those are our points, right? Now, remember, do not just give me points or ordered pairs. I said before, I want you to then, using a ruler or a straight edge, I want you then to connect them and make it a line, which means it has to go on both sides. Is that a proportional relationship? Yes. It is a proportional relationship. By the way, when you do y divided by x, when you're finding that k value, what would the first k value be? What is 1 divided by negative 2? Perfect. And by the way, I want to show y'all really quickly, for those of you that aren't sure, when you do y divided by x, and you get 1 over negative 2, you can leave it as a fraction. The only thing I told you yesterday is to never have a negative in the denominator. So this is simply negative 1/2, right? What's the second one? What's 0.5 divided by negative 1? It is negative 1/2. This is negative 1/2, and this is negative 1/2. So let's go to the second one really quickly. Let's graph this second guy. Spoiler. So we plug everything in, same process, right? So negative 3 times negative 2 is positive 6. 6 plus 2 is 8. That's 3 plus 2, which is 5. That is negative 3, negative 1, and negative 4. So let's graph these. We have negative 2, 8. That doesn't even go up that far. So we end up with negative 1, 5, which is here. 1, negative 1, which is here. And 2, negative 4, which is here. Now here's my question. Is that linear? Let's see. Yeah, that is absolutely linear. Yeah, well, I want to make sure you understand. That is indeed a linear relationship. Okay, if you were to put a protractor or ruler to that, but, Tara? Yeah, if you go ahead and try to find the constant of proportionality and do y divided by x, they all end up being different. Plus, we know it's no longer proportional because it doesn't go through the origin. What makes one proportional and one not proportional? Leilani? Okay. Tara? If you look at the two equations, this is what we're going to talk about today. That constant that we add or subtract at the end changes things. Brendan, don't need that out. That constant at the end of an equation changes things. Oh, and by the way, let me just show you a quick trick and then I'm going to let you go. Where does the bottom one, where does it appear to cross the y-axis instead of at the origin? Where does it cross, Alex? Huh. Huh. In a proportional relationship, we want it to cross, Andrew, put that away. In a proportional relationship, we want it to cross where? Which is? What number is there when you don't see a number?
0.
Yeah. That is what tells you if an equation represents a proportional relationship or not, whether there is a constant added to the end. Okay? So when we get back from lunch, that's what we're going to talk about. Make sure your warm-ups get thrown away. Okay. So, done. When you are given a particular table, when you're given a table, I do want to spend a little bit of time and talk to you guys about quick and efficient ways for you to find the k-value. The k-value becomes McGee. Ready? Okay. The k-value becomes something that's very, very important. I will tell you that the equation, this is the equation that you use, the standard form of an equation for proportional relationships. It's a standard form of an equation for proportional relationships, which means that if you can identify the k-value, you can identify the constant of variation, then you can write the equation for any proportional relationship. How do you find the constant of variation? Alex? Y divided by x. And you need to make sure that every y divided by x represents the same number. Okay? Now, sometimes they're easier. Sometimes they're easy. You end up with an xy table, and you end up with, say, -8, 16, -4, 8, 0, 0, 4, -8. What's the constant of variation? Christopher? No. Yeah, okay, so I'm sorry, go ahead. Okay, so the constant of variation is -2, not x, just -2. Because remember, guys, you find the constant of variation by simply doing y divided by x. In this case, it's 16 divided by -8, and 16 divided by -8 is -2. 8 divided by -4 is -2. -8 divided by 4 is -2. That's the pattern. Which means that to write the equation for this, it would simply be y equals -2x. Simply take the k value, plug it in for k, you're good to go. Okay? Now, when it gets a little bit odd is when you end up with tables that are not quite so obvious. By the way, while I'm doing this, What if you were given a graph and told to write the equation from the graph? How could you, okay, how could you do that, Labib? You could do it that way. You could take every ordered pair you see, put it into a table, do y divided by x, and identify your k value. That's one way to do it, right? Alex? Yep, you could do that too. Wait. Okay, so let's try this. If I said, is this a proportional relationship, where would you begin, Alex? Okay. I would start at negative 4, 3. You have two integers. I disagree. I never started a fraction. And I'll tell you, because when you're looking to identify y divided by x, right, you literally have 3 over negative 4, which is simply negative 3/4. There's no math really required for that. Now, if you have, let's go down here. If you end up with negative 1.5 over 2, you double both, which gets rid of your decimal, and you end up with negative 3/4. Yeah, because it's sometimes difficult. I don't know of any kid that wants to necessarily do division, do 1.5 divided by 2. You don't really have to. You can leave it in fraction form, but they have to be integers top and bottom. So if you have 3/4 over negative 1, which is essentially 0.75 over negative 1, what is 0.75 divided by negative 1? Just becomes the negative value. So it's negative 0.75, which is negative 3/4. In each of these cases, you're ending up with a standard k value. Andrew? It, well, it was initially negative because it is negative, and then I moved it. I never let the negative. I'm not saying you can't have a negative in the denominator initially. I'm saying it's not considered simplified for you to leave a negative in the denominator. Okay? So if you end up with an answer that's 1 over negative 2, don't give me this as an answer. Yes, not simplified. Yes. Because we said so. I don't really know a better way to say it. You'll know when we get to slope why that's the case. Okay? Bennett. Me and all the other math geniuses that will be teaching you math throughout the course of your life. Yes, there are some genius elementary school math teachers. No. There are way too many bodily fluids in elementary school. There's snot and crying and wet shoelaces. Yeah. See what I'm talking about? Yeah, the boys know what I'm talking about. There's nothing. Can you imagine? Because the elementary school teachers have to like when you can't tie your shoe and you're in first grade, have to kind of help you tie your shoe, and they reach down to help you tie your shoe, and they grab your shoelaces, and they're all wet. I just threw up a little. Okay. So, Christopher. Oh, no, no, no. I don't need, no, no. I do not need that. Write a book and we'll read it later. Okay. Alrighty. Now, before we left, we talked about equations. We talked about equations. How did we discover we can determine from an equation standpoint whether it's proportional or not, Jason? How do we determine from an equation whether a relationship is proportional or not? If you don't add a constant, that's exactly right. If it is in the form y equals something times x, and at any point they add a constant or subtract a constant, any number, it's out. And we also discovered what about that constant? It ends up being where it crosses the y-axis. Christopher. What do you mean add y? You wouldn't do that. You won't see that. You know why? Because your goal is to get y by itself. So when you subtracted y, what happens? They would both go away. Yeah. Yeah. You won't see that. I'm just saying you won't see that. So proportional or not? Proportional. How can you identify the k value? What would be the k value in this? There is none. Very good. Because you can only have a k value when it's proportional. Okay? Okay? It is. You know why it's m? Why'd they use m for the variable of slope? It's so not true. They had sigma. Look it up later. Okay? Yeah. I just want to see if you knew it. No. There actually, there is a rumor that the reason it is because the French played a fairly big role in mathematics, and there's a weird French word that could mean slope that starts with an M, but when you do research about it, basically no one can figure out why M is slope. No one knows. They just kind of picked it. There you go. Just happened. Sometimes things don't have an explanation. Now, listen up.